or reactions in B. So as you can see, we have a system that consists of two parts that are pinned together, and we apply force 400 newtons to the right, and all we want to find is the reaction at point B. So what should I do? Again, I have my 5-step algorithm. Choose the system, draw FBD, write equations, solve them, and verify. Those 5 steps. Every time we solve a problem, we have to do these 5 steps. Alright? So, kind of go through it. First, system. What should I choose as my system? I have 2 parts. 1, 2. Well, because this point P is shared between 2 parts, it's kind of like tangled between 2 parts. I have to choose 2 parts as systems. Right? So I'm gonna have 2 systems. One, this L-shaped connector, and then the other one is the arm C, say B, C, A, and B. So let's call this system 1. Let's call this system 2. Okay. Now, I check mark step 1. I did my system. So these are my system 1 and 2. Now draw FBD. For every system, we do FBD. So here, again, if I draw that dash line envelope and start walking to get surface forces, how many force and moment do I have at B? EXCY. Do I have a moment? No, because it's pinned. Friction is pinned. Right, I can easily rotate it. Nothing is going to resist me. I come back to B. At B also, I'm going to have 2 force BXBY because it's pinned. No moment. And these are all possible surface forces. How about the body force? Well, assuming that the mass of all those 2 connectors is 0, almost massless, so there is no body force, no significant gravity, right? Body force. So I'm done with system 1. Now let's go to system 2. For system 2, at point B, I just put the opposite of whatever I defined here, dx, dy, and I'm going to have 400 here, and then I'm going to have ax, ay, no moments. And that's all. That's my free body diagram. Now check mark it, go to the next step. Next step is write equations. First of all, before I write the equation and solve them, I ask the question, can I solve this problem? Can I solve this problem? How many unknowns do I have?
6.
1, 2, 3, 4, 3, 4, 5, 6. 6 unknowns. How many equations?
6.
2 systems. Every system has 3 equations. 2 times 3, 6. 6 equations, 6 unknowns. Can I solve it? Yes. So let's write the equation. Summation of force x0 for system 1. Equation system 1. So that's going to give me dx plus dx is equal to 0. Summation of force in the y direction, 0. That's going to give me dy plus by is equal to 0. Summation of moment. But the point is 0, any point. What point should I choose? D or B? D. Because if I choose B, what happens is B would disappear from this relation here. And I need B, Bx and By, because that's the only way I can communicate to system 2 from system 1. It's through Bx and By. So if I can find out Bx and By, one of the system, I can put it in the other system and solve for unknown, right? So I would choose B. So summation of moment about B is 0. What do I get? I get 0 from here, 0 from here. What about Bx? Move it. Where should I move it? Back here. So it's going to be Bx times 0.2, positive or negative? Thank you. By, move it. Where? Down. So it's going to be from here to here. So it's going to be By times 0.2, positive or negative? Positive. Thank you. What else? That's it. Is equal to 0. Now, let's go to system 2. Because we're still working on writing the equations, right? System 2. Summation of force and x2. That's going to give me 400 negative bx plus ax 0. Summation of force and y 0. That's going to give me dy negative plus ay 0. Summation of moment around any point is 0 as long as it's equilibrium. What point should I choose? Well, the competition is between A and B, because this point only has one, and that is known. We're trying to find a point that has most of unknown going to that point, right? So, because of the reason that I just mentioned, that B is the only point to communicate this T system, then I don't want to take B, because B is going to vanish. So take A. So, this is going to be point A. So what do I get? Let's start with 400. 400 times 0.7. Positive or negative? Negative. Then go to Bx. Bx times 0.2, positive or negative? Positive, and then you go By times 0.2. By times 21. Positive or negative? What else? That's it. 0. Now, here comes the interesting point. Which one should I start with? Well, like always, we're trying to find one equation, one unknown. To get the numerical value and substitute it back to all equations and get all the unknowns, right? Now, if I come here, this is one equation, two unknown. Can't do it. Can't do it. Can't do it. Come here, can't do it, can't do it, can't do it. Then at this point, I may say, I can't do it. But I say, wait a moment, I had 6 unknown, 6 equations. So this system is solvable. Because you have the number of equations equal to the number of unknown. But how can I solve it? Well, if you look at this equation, what do you get? Let's start solving it, because you know what? We're not going to do anything new, as I said before. We always do these 5 steps. Always. To the end of the semester. So, what I do, I solve this equation, but I don't expect a numerical value. I just expect a relation. And then I can use that relation, like Gaussian elimination. You remember that? We had to find one of the unknowns in terms of other and substitute it back. That's exactly the same thing we do here. So if I solve this equation, what do I get for Bx?
Bx equals By.
Bx is equal to By. So just take this to the right side, divide by 0.2, then you get Bx is equal to By. Now, what is my next step? Plug in
By or Bx instead of.
Yeah, 6. Plug in the 6. So if I plug into 6, Bx is equal to By. So I just get either put Bx or By, one of these. Let's keep Bx and By instead of By, just put Bx. So this equation would simplify to Bx times 0.2 plus 0.1, 0.3. Right? Is equal to, take this to the other side, 400 times 0.7. Then solve this for Bx. Bx is equal to 7/3 times 400. That's it. Put it in a calculator. $933. So is By. The same thing, 930. Now, if you can see, I can get Dx because I have Bx. And I can get Dy. Right? The last thing I can get Ax and Ay because I have all of it. So my entire system, I can get everything. Although the question was just find Bx and By, not A and B. Question was just find this. Now we want to, so you can see, you all can see that we can solve this problem by our standard 5 steps. So I wrote the equation, I solved it, and how do you verify it? Well, verification is usually based on intuition. So you say, if I put the 400 volts like that, push it like that, then this arm should apply a pulling force on this L-shaped connector. So it's going to pull it that way. So if I choose Bx, this sign, like this way, it should be positive, both Bx and By. Maybe not sure about By, but Bx must be certainly positive. Now you come and look at the value, it's positive 933. If you had a negative, that would be terribly wrong. Then you should go and reconsider where you messed up the sign or directions. Right? So that's a step to verify. Now we verified and it looks right, that example is right. Right? Now I want to show you a trick. It's called two-force member. Member that only has two force. As you can see, this L-shaped connector has two ends, and there is one force here, one force here. Right? Now if we just consider this member, let me draw it here. Let's draw the general shape of member. It's not necessarily L, it's arbitrary shape, and has two ends, A and B. Point A and point B. Let's say this is connected, this is in a mechanism, in a very hard, very long mechanism. And this is pinned to a mechanism, a very long mechanism, right? So what I have, if I draw F to B, I'm going to have AX, AY, only two components here, no moment, right? and Vx, Vy here. No moment here. This is general FVD. And assuming that it's massless, frictionless. So a member of arbitrary shape, massless, frictionless, pinned to 2 points, right? So what can I say about this particular configuration, particular member? Let's say this distance from here to here is B, and from here to here is A. Let's say these two are given to me from measurement, right? In that particular example, A is 0.2 and B is also 0.2, right? So this end-to-end distance are given to me. So, assuming this is in equilibrium, I want to write the equation of what? Point A, 0. What do I get? Bx times, what should I do? Move it. Where should I move it? To get a moment with respect to A. All the way here, right? So Bx times, B positive or negative? Bx times B positive or negative?
Positive.
Negative.
Negative. If it's not positive, it's negative. So if you move it here, right, Bx times B is negative. Then you go to By. By times A. Positive or negative?
Positive.
Positive. Is equal to 0. Now just rearrange this system. Then you get By over Bx is B over A. This is a very important relation. What does it say?
Force is relational to the distance.
It says the forces at B, the component of force at B, are proportional to this distance. Or, in other words, it says whatever force you have at B is acting a line that is connecting point A to point B. So let's draw a line in order to see that. Let's draw a line from here to here. And this is B, right? The resultant of Bx and Y. This is a vector B. This is a component. So as you can see, consider this triangle and this triangle. So in this bigger triangle, B over A is the tangent of this angle. What about tangent of this angle? By over Bx. So if By over Bx, which is tangent of this triangle, is equal to this triangle, these two angles are equal. Theta 1, theta 2. Theta 1 is equal to theta 2. That means the direction of force is aligned with this line that going through A, going from A to B. So for this particular member, if you see it in a structure, this is called two-force member, as long as it's massless, frictionless. So all you do, you say, I connect a line from beginning to the end, and here in this member, I only have two force, and they're equal. They're equal. So you have, if you have B here, then the opposite equal and opposite is on the other direction. So when you draw FVD, you draw FVD like that. Now I show you this will accelerate your solution. Instead of introducing dx, dy, dx, dy, you only have one unknown b, and you have the direction of it. Now let's say, considering this fact, now let's solve this problem one more time. with this trick. Now I choose a system, what are my system? Two members. Then I choose a draft FED, and then I write equation, solve them, and verify. Exactly the same 5 step, nothing new. But the procedure is going to be faster if I consider the fact of 2-point member. So this is system 1. And this one is system 2. So I said, this is the 2-force member. Then what I do, I just connect end to the end, and my unknown force is going to be one this way, one this way. And let's call it B. Because it has point B. We have the same B going this way. Right? And this angle is what?
Theta.
Is what?
Theta.
Is theta. And according to this figure, it's 45 degrees. That's right. So theta, 45. So in fact, this angle is 45. Right? Now let's go to system 2. This was system 1. Okay? System 1. Now let's go to system 2. Again, I'm gonna have a 400 here. Right? Opposite of this. With angle 45. And then AX and Y. You see, instead of having 2 unknowns at point B, I only have 1 unknown, the magnitude of force B. But I have a direction. The direction is 45 degrees. Right, so I only have 1 unknown. Now, I want to solve this problem. How many unknowns do I have?
4. 3.
3. So in fact, I can just consider this system. Instead of 2 systems, I can accelerate my job or solve the problem with just 1 system. So this is something, right? This can help you to accelerate your solution. Now, if I write the moment equation from with respect to A, what do I get? The magnitude of B. What the problem is asking for. B. So in fact, I can solve this problem with just 1 line. Right? So you write moment with respect to, so in system 2, moment with respect to point A, 0. I get 400 times this distance,
0.7.
0.7. Positive or negative?
Negative.
Negative. And then I go to this guy. So that's going to be magnitude of P times cosine 45 times this distance, 0.2. Positive or negative? Positive. Magnitude of B times sine 45 times, say it.
Point 7?
0.1.
0.1. Positive or negative? Positive, right? Is it equal to 0. Then you can solve for b. In fact, b is equal to 400 times 0.7 divided by 0.2 sine 45 plus 0.1 sine 45. You see, you could solve it with one line, just starting from scratch, as long as you know this concept, two force member. Member that only has two forces at the end. If you massless frictionless, you only have one single force that is opposite, equal opposite at this end. And the direction, you don't have the value, but the direction you have it is along with the line that is connecting two ends together. It doesn't matter what shape you connect it as. Okay? So when you compute this, another point is don't forget, don't compare it with this value, 133, because this is the value for bx. And this value you get here is for the value of vector b. In fact, this should be equal to the square root of bx square plus by square, which is 933 square. Should compare it like that. Alright? Now let's go to a 3D example. Sorry, we don't have enough time.